I welcome you all to the Spark Research YouTube channel. This is Dr. Virchandra, Assistant Professor in the Department of ECE, and here we are going to analyze the GATE previous year question, not previous year, this 2026. So this is the first session of this GATE 2026. So in this series, actually, we are going to analyze all the questions from the depth. So Organizing Institute is your IIT Guwahati for this GATE 2026, and if you are preparing for this GATE 2027, it will be very helpful for you, so that you can actually understand that what type of the questions may come in the next year. So if you are preparing, then you can go through these analysis. So in this session, actually I will target to analyze it from the very detailed analysis, right, from the depth, so that you can understand even if you do not have the proper idea. Means we are going to start it from the very scratch. Okay, so let's take, so in this session, actually, we are going to take the questions from this analog and digital communication course, and the topic particularly is pulse code modulation, that is PCM. So we are going to take these questions based on this. Okay, so here is the syllabus for your analog and digital communication, and if you'll check it, these communication may be distributed in the 4 parts, 1, 2, 3, 4, and the last part is the digital communication. And the first topic of your digital communication is the PCM, that is pulse code modulation. So question has been asked from this portion particularly. Okay, so let's take the question. So your question number 15 is, two analog signals, that is X1 and X2T, are sampled at rate of fs is equal to 40 hertz. So we have to understand what is the meaning of these x1 and x2. So these are the two analog signal. Analog signal means varying like this. So analog signal means simply the axis, the time axis and the amplitude both are continuous, right? That is analog axis, analog signals, both are analog signals. And now we are trying to convert this analog signal into the digital signal, right? So how will we convert? We are going to use the some sampling technique. So PCM is a one of the the very popular way to convert the analog to digital. So that have the two, actually the two steps. So first step is the sampling, and second step is the quantization. So this question is related to the first step, that is the sampling. So in this question, x1 and x2 both are the analog signals and sampled at a rate is given. So this is common for both, right? So x1t and x2t, where x1t has this expression and x2t is the signal like this. Now question is being asked that the first 10 samples starting from t is equal to 0 are considered for the analysis, right? So we are going to take the 10 first samples. So what are the options? Option is that all the first 3 samples of x1 are greater than the corresponding samples of x2t. Means we have to check the 3 samples for x1t and x2t, right, after sampling. In second, last 3. So in second, they are considering last 3, means total we are going to consider how many samples. So we are going to consider total 10 sample, right? Out of 10, first question is asked for first 3 samples. Second option is being talked about the last 3 samples. Similarly, the third option, that is all the samples are greater than the corresponding samples of, they are talking about the all the 10 samples. And the last option is talking about the all the 4 to 7th samples of x1 are equal to the corresponding samples of x2t. So last option is talking about the 4 to 7. Means in short, we are going to find the samples of the signals of x1, 2 and x2t, right? So as per your answer key provided from the IIT Guwahati, option D is correct, means the last option is correct, where the 4 to 7th option are equal to corresponding. Okay. So like in the very short discussion, if I will tell you, so see here the sampling frequency is fixed for both, right? X1t and x2t. So if you are going to find, if you are going to sample x1 and x2t, then check whether the samples at these sampling rate are same or not, right? So how we'll check? So let's see here. So first of all, whenever you are going to sample x1 and x2, like so, now we are going to represent x1n. Why is this so? Because after sampling these things in the discrete form, and whenever discrete form will come, means instead of the n we are going to use the t. So T will be what? NTS. So that is how you are going to convert into the discrete. And in this question particularly, it has already given that sampling rate is 40. So NTS will be N divided by 40. And then you can also rewrite x1t is equal to cos of, the twice pi and the sampling rate. Instead of the t, we are going to use this NTS, right? So replace this t by NTS and get the cosine here. So then you can get the cos is equal to pi n divided by 2. So 20 divided by 40, Okay, similarly x2t you will get the cos of 5 pi n divided by 2, right? So these are the sampled data, right? Both. Now what will happen? Now we can simplify the digital angular frequency of x2t by subtracting multiplies of twice pi discrete time sinusoidals are periodic with the period of 2 pi. Since your sine theta and cosine function both are the periodic function of the 2 pi. So if you like see here, this is 5 pi n divided by 2. So if you can rewrite the 5 pi n divided by 2, that is twice pi n plus pi by 2, right? Why are we trying to write? Because we know that this is the periodic function of twice pi, right? So we can write cos theta plus twice pi is equal to cos theta. So similarly, you can write cos here. You can rewrite from here cos x2t is equal to cos of twice pi n plus pi n by 2. So finally you will get x2t is equal to periodic function of what? Cos of pi n by 2, as same as x1, right? Means what? X1 and x2 both have the same period of cos of twice pi function, that is pi n divided by 2. Then what will happen? Now if you are going to sample the same with the same rate, then at all the states x1 and x2 will contain the same values, right? So first option is telling three samples are exactly equal, like all samples will be equal now, because see here the x1 and x2 both have the same type of pattern, right? Cos of pi n by 2 means x1 and x2 both will the follow the same pattern. So in that case, whenever you are going to sample, what will happen? It will have the same values. So first option is telling that greater than, so that's not possible. Second option is telling last three samples are the greater than also exactly equal, but exactly both are equal now. First three samples, last three samples, and 4 to 7 sample, that is in the option D, all are the equal. So option D, that is why is correct, because option D is only talking about the equal. Otherwise and all remaining options are talking about either greater than or lesser than. Okay, so now we will discuss the some more about the basics, so that if you do not have the idea about this sampling, you will get it, right? So here see, this is the blue color is showing the your analog signal, right? Blue color, this is the analog signal. And here now whenever you are going to sample, so you are going to sample like this, right? This is the actually the sampling rate. So I am dividing on the x-axis, so this is the sampling. And after sampling, the if you want to convert the same signal into the digital, in that case what to do? You have to convert into the you have to also change the amplitude to a particular fixed values, means that is called the quantization. So these are the sample values, means just dividing on the x-axis, but at the same time if you will fix it the y-axis values here, these values, then finally you will get the the quantized value, so that will be called as the quantization. So this is that finally that will convert the analog into the digital signal. Okay, so there is a certain rule. One rule is that Nyquist rate. So whenever you are going to sample, then it must be the value that is twice of the f of highest frequency that contains in that particular message, right? So suppose message contains the frequency of f of m. So in that case, what will be the f of s sampling rate will be twice of f of m. That is called the sampling frequency as per the Nyquist rate. And what will happen if you will sample at lower rate? Then it will have the aliasing. Aliasing means the you cannot recover the message properly, means it will have the error. And if you will keep the higher, then definitely it's good, no problem, you can have the better signal. But problem, you can reconstruct the message, that's fine. But problem is that if you will keep it very high sampling rate, in that case you may need the higher memory. So it's okay, you can do the sampling at higher rate, not a problem at all, right, from a reconstruction point of view. Okay, so here is the sampling theorem, you can check it. So here in order to reconstruct the message, the same things has been repeated, that is it must be greater than twice of b. And so this is the analog signal. And whenever you are sampling using the impulse responses, and then you can have the for each responses you can reconstruct using this Fourier transform. So for each of them you will have these type of the shape. And under the low pass filter you can use this low pass filter to avoid the higher frequencies, these frequencies, and then finally you can recover the masses, right? So this is called the Nyquist interval or Nyquist rate. Okay, so again if you'll check it, the same questions here. So first of all you have to convert your original message into the discrete message. So here you can write x1t, and here you can write the x2t, and x2t again the cos of pi pi by n. So since this is the periodic function, so you can rewrite that is cos of twice pi by n. Now here is the image for your x1 and x2t. So red color is showing the x1t. So you can see here it have the very high frequency, that is cos of 100 of pi of t. So frequency is 50 hertz. And for blue color you can see here it have the very less frequency. In this case your frequency is how much, 10 hertz, but sampling frequency is fixed, that is 40. So since the sampling frequency is same, the so it doesn't depends on the frequency of your message signal. So wherever you are going to sample, values will be different, definitely the amplitude will be different, but the sampling time at that particular sampling time now, that will be the equal for both x1 and x2t for all the interval 1 2 3 4, then 5 6 7, right? So for here 1 2 3 4 5 6 7 8 9 10 for all these samples, right? So both will have the same values on the time axis. So amplitude will may be the different. So here the for all the corresponding samples are identical, the statements. So all the samples 4 to 7 x1t are equal to the corresponding samples of x2t. So that option is correct. Okay, so that's all in the session. Thank you to join. So play today, stay healthy tomorrow, and learn for a lifetime.